So it's been some time since I've wanted to do this. I've been busy with this machine for probably about 8 months. My pride and joy, it's given up, and I've considered now, well, not considered, but I've made the decision to retrofit it because I definitely do not want to get rid of it. I've been quite busy. I haven't had the time to actually make a video about this. You can see it kind of looks like shit around the machine at the moment, but I've been busy. So just a bit of background. I bought this machine basically for scrap value. The company that had it and owned it maintained it very well, had people come and sort out the machine all the time, and they had it from brand new. And I heard that they were going to scrap the machine to make space for a new machine that they bought. Obviously, when I heard scrap a machine, I was immediately interested. I went to go and have a look at the machine. Obviously the price, I mean, I couldn't say no, and that included delivery, because the rigging company that was coming to remove it and take it to the scrapyard, that was already included in the price. So instead of taking it to the scrapyard, they just brought it to my factory. I found out what the problem is because the company didn't want to put any more money into the machine. I found out what the problem was, and the machine ran absolutely beautifully for probably 2 years, and I could keep the machine running because I had so much spares that this company gave me. There was 3 of these machines in Cape Town, and I basically had all 3 of them. They scrapped the other 2 and kept all the parts to keep this one alive, and I basically ran out of spares. And well, I didn't run out of spares, but I ran out of the servo drives to control the servos, and there wasn't anyone helpful enough and obviously within a budget to help me diagnose and repair the drives. So I ended up making the decision to retrofit this machine with a Linux control system. Yeah, and I've been busy with this for probably about, I want to say 8-9 months. I've been busy, and as I started retrofitting the machine with Linux setup and all that, I realized that wasn't my initial thing I should concentrate on, and I should concentrate more on the wiring and getting all the wires in a state where I can just basically plug and play them into the Mesa cards that I have. And I started focusing on redesigning and reverse engineering the standard the PC board. This is the original distribution board, or well, an extra one that I have of the machine. And so I started focusing on reverse engineering this PCB. I obviously have all the manuals, all the wiring schematics, and all of those things, and I started focusing on that. And it's been tough and a very big learning curve, but I have managed to reverse engineer the PCB. And the only reason why I wanted to do this was I didn't want to create a bank of DIN rail mounted terminal blocks, and I have to cut all the wires and have them placed in position. So yeah, that was the reason why I started making this PC board. And this is the result of the main distribution board, and now everything just plugs back in where they were supposed to be. So everything plugs in, and then these would obviously be all my inputs that would go to the MISA card. These terminals are just going to have wires that will go straight up to the MISA card, and then obviously I can just allocate all the terminals in Linux. These are all my outputs. It's a bit of a mess at the moment. I just got the PC board, and obviously it's been a while, and I just wanted to plug it in and see that everything works. So far, the stuff I have tested works. Obviously there's a lot more to it than just this PC board. Obviously on the old machine, on that controller, it had output cards that had fuses and everything in them, and was able to be monitored, the fuses themselves. If something went wrong, the control system knew about it. So that became my next thing that I had to sort out, was being able to monitor the outputs, and if they are actually on. Obviously Linux thinks they are, knows they are on or supposed to be on, but I had to know if they are actually on or if there might be a fault. So obviously the machine has a hydraulic system and solenoid valves and so on. So obviously for the chuck, if Linux thinks the chuck is powered and it's not, that would possibly cause quite a big issue. So that's the thing I'm busy with at the moment. The other thing is, this machine was designed to run on 220 volt 3-phase and not 380 volt here in South Africa. So it came with a huge transformer, which I've bypassed now so that I can get 380 volt at the machine. So there's quite a it's quite a big story. So this looks like shit at the moment. I just mounted the new toroidal that I got made to step down from 380 volt to 220. It looks terrible at the moment, but it's controlled chaos. The new drives I got, so the new drives, they're not powered yet. I'm not ready for that yet, but everything at the moment works. I haven't started with the controls yet. This would obviously all be removed. This is all getting removed here, and then just being replaced by basically just this bank of switches, which is all still in the wiring. Everything is plugged in as what it was. Just going to be a new user interface, but the switches are all going to do exactly what they did. This is getting completely removed. I'm just replacing the keyboard with a standard keyboard, and the screen that I got is touch screen, which is not ideal, but I made provision to add switches and whatnot underneath here, just some panels. This is quite a big learning curve, and I was not expecting it to be this difficult, or I just lack the knowledge to be able to do this. So obviously the learning curve involved is huge. The stuff I'm busy with at the moment, you can see this is the PC board that I've developed to be able to monitor all the fuses. These are all individual fuses here, and yeah, it's a big learning curve. So just some optocouplers there just to sense the 110 volt optocouplers, and then this would be the signal output side where I've just got 0 volt DC, 24 volt, and then my signal output that will go to Mesa card to tell me that on this board there's a fault. One of the fuses blew. So that is this board. Then obviously there's quite a bunch of relays on the machine as well. That's the next. I think I'm done with this board. I wanted to add an LED or an indicating light, but because I lack the knowledge to figure out how the hell I can make it work. I think with some kind of a transistor or something, I could probably get it to switch just a LED on, like a red LED or a green LED that would be on if everything is fine, and then switch off once one of the fuses blow. The other boards that I'm busy with is the relay board. Yeah, I think just a bit of background. I've got an engineering workshop. I've got CNC mill, another CNC lathe, and got a big lathes. Yeah, and we're quite busy. But this machine hasn't run in like a year, so I'm quite focused on that to try and get it going. So my relay board, back to the relay board. So this is kind of the relay board that I've got going here. And this would have all the relays on that, kind of has all the safety interlocks on. Now I'm not done with this board yet. Obviously I didn't know how to design a PC board. I've designed a PC board before in my life, but nothing as complicated as this. Well, this isn't even actually complicated, it's a big learning curve. So these would be all the relays that just run basically the start up. So there's some latching relays here. When you press the master start button after you've powered up the machine and you press the master start button, there's some latching relays in here, and then also the servo drives on, spindle on, those types of relays are all on this board. Now I'm not completely done with what I actually want this whole setup here to do. Obviously there's some safety interlock. I need to, if one of the fuses on the board, on those other boards blow, I think I still want to put a relay in here that might not allow the servos, or maybe just go into like an e-stop state. Yeah, so this is that relay board, and then obviously I've got that sensing board, which is this one, and then the main distribution board, which is the one that I showed you earlier, would be this one. Took me the longest. This was the one that I thought I would be able to finish and then have the machine actually functional, where I could hook up the MISA cards and everything, but that wasn't the case. Obviously, as you go, you realize other problems or other things that you have to do to make the machine more robust. And yeah, so yeah, this took me a few months to do. This was the first one I did. Obviously I've got Fusion, and they've got the PCB function. Seems to work okay. It's quite difficult to figure out if you know nothing about developing a PCB, and then obviously pulling the trigger to get something made that you don't know is gonna be fine. Yeah, so I've been wanting to keep track of this whole project and take videos and whatnot, but I just haven't had the time. I guess if anyone wants a bit more advice, or maybe has the same machine, I've got plenty of spares. I've got a lot of spares, like literally a whole mezzanine floor full of spares. Control cards. All the control cards on that machine, the SAM board, which is the servo control board, like that whole section over there is basically just spares from that machine. The machine worked 100%, just I couldn't get the servo drive repaired, and that was literally the only issue. I don't know if the issue was actually with a servo motor itself or the drive, but yeah, there was a few bangs. Yeah, so if anyone wants a bit more advice or